All right, good morning and welcome back. Today we're going to start the next part of our chapter, or we're treating it almost as a separate chapter, but this one is on graphing of our sine and cosine. And so first we're going to kind of talk about the basic form of what kind of functions these are. These are wave functions, as they're often seen in the physical world. And so first, let's examine a wave function. So as you can see, this would be an example. It looks like a wave, right? It goes up and down and up and down, and it continues in both directions. The best example of like why this is going to be important for us with sine and cosine in our unit circle, if you think about if this Ferris wheel was our unit circle. So right now it's starting down here. That red one is what we're concerned with. When I hit go, you'll notice it spins around, and you can see as it goes, the little red icon here goes up and down and up and down, and that's tracking its height with respect to time. So as time increases, the height goes up and then down and then up and then down, and that is kind of what is happening with our sine and cosine on our unit circle. Okay, and we'll continue to talk more about that. But first, we're going to kind of examine these wave functions and say what parts of it do we actually care about. So one thing we care about is our midline. Okay, and this is just a horizontal line. Okay, it's a horizontal center line that runs through our function. And the function is going to oscillate above and below this line. So if we, oops, I misspelled that. If we go ahead, here, give me 1 second to finish this, and then I'll show you what I mean. Okay, so first thing we want to do is think about horizontal. So horizon, you know the horizon runs like the x-axis is horizontal. Okay, so it's going to run from left to right or right to left. And it's a center line. Okay, so if we look, find a peak, find a valley, the distance in between those, 1, 2, 3, 4, 5, 6. And it has to be halfway in between. So up 1, 2, 3. And this is our midline. Okay, so the same amount is above and below. Now I don't mean the same amount of peaks or valleys. I mean that it goes 3 up and 3 down. Okay, that's our midline. Now, since it's a horizontal line, if we were going to write that as an equation, your midline will always be something like this, y equals, okay? And in our case here, it would be y equals -1. Let's go ahead. We'll do the second one on the page. So we find the midline, up 1, 2, 3, 4 total. So at 2 here, here's the midline. I'll draw it in. Now that midline is technically not really on there, but that can be helpful for us. Okay, so it is at y equals 2. So the midline, pretty simple to find, just basically a line that runs directly through the center. The function continues above and below, okay, the same direction in each way. Now, amplitude. This is that distance from the midline to the peak or the valley, okay? So amplitude, think of it kind of like your height. So it's the distance from the midline to either the peak, which is our maximum, or to the valley, which is your minimums. Now, if we look at this first one up here, so we start at the midline, up 1, 2, 3. Okay, so that is an amplitude of 3. Now maybe some of you counted the other way, down 1, 2, 3. Even though that's down, it still would have an amplitude of 3. Amplitude is distance, so amplitude will always have to be positive. And if we look on this one, the amplitude up 1, 2, or you could do down 1, 2. As long as your midline's correct, your amplitude is super easy to find. Amplitude of 2 there. Now finally, this last one is a period. And this is the length of one cycle of our wave. Okay, now I'll explain what I mean by that in just a second. So the length of one cycle of the wave. And so what I mean by that, one example of this might be like peak to peak. That's a cycle. If we look here on this second one, if I start at y equal, or on the y-axis right here, and it goes down and then it comes back up, and one cycle is completed here at 4 pi, that would be our period. We're going to say 4 pi is the period because it takes 4 pi to get from one peak down and back up to the other one. Now, unfortunately, sometimes it doesn't start on our peak, so that's okay. Like here, it started down, like on the y-axis, it was at the midline. But be careful. Some of you are going to be tempted to tell me it's pi over 6 because that's how long it takes to get back to the midline. But if we think about it, there's another part. We need it to replicate itself. So we have to go all the way to pi over 3 because until that point, it has to go up, then it has to go down. Then when it's back at the midline and it goes up again, that's when it repeats. That's when the cycle repeats again. Okay, so one period on this one would be pi over 3 because once again, if we start here, it goes up and then down, and then that's when it starts to repeat itself, hits the midline and goes up again. So right here, pi over 3. And if you want to see an example, so if we had, let me see if I can get this to a better shot. There. So right now, it's starting over here on the right side, kind of where we're used to on our unit circle of 0. And as I hit go, it spins around and it comes down, and then I pause it, and I went a little too far, but you can see it started to spin around the circle again, which makes sense. It went from here, it went around, and then right at this point, as you can see, I'm a little bit past that point. So let me reset it and try it one more time. Right now, it is right at the origin right there. As I hit go, it spins around, comes back, and then right there. Once again, I'm a tiny bit past, but that is how long it takes for one cycle. So that is one period. Okay. So if I were you, what I recommend doing is flip it to the back, and I would say try to see what you can answer on these. Okay. So I'm going to work through it, but if I were you, just pause it real quick, see if you can identify the midline, amplitude, and period of each of these. So number 3 here, our midline, once again, it goes from -5 up to 3. That's a distance of 1, 2, 3, 4, 5, 6, 7, 8. So 8 divided by 2 is 4. That 4 is what your amplitude will be. And you know it has to be 4 from both the top and the bottom. So that will occur here at -1. That is in the middle. And so y equals -1. Now, once again, we got to find what is my period. So I can start here at 0 on the y-axis, and I go up and down, and the cycle repeats here at 2 pi. That's where it hits the midline again. Now, maybe you prefer instead, you want to go peak to peak. That's fine. You could start here. This is at -3 pi over 2. And when it goes down and then up here to pi over 2, So that would travel a distance of 3 pi over 2 and pi over 2. And if we add those two together, 3 pi over 2 plus pi over 2, we would get 4 pi over 2, which is the same as 2 pi, which, as you can see, that's what we had as our radian. So it's not like you have to go from one spot to the other. You could start here and go until it repeats itself at pi. So negative pi to pi, that's a period. The key is one cycle, okay? And it will be consistent throughout the entire wave function. Okay, our next one. To find the midline, we go, what runs through the middle. This one's pretty easy to see. Y equals 3. The amplitude, it's 1 above and 1 below, so that's amplitude of 1. And now we look, starts at the peak here on the y-axis. The y-axis is just a nice point because it's like very obvious where it is. So it goes down and then back up, and that also has a period of 2 pi. So it takes 2 pi to get one complete rotation of the wave function. All right, our next one's below the x-axis, but it's the same process. We find that center line, or the midline, and it's at negative 3. 2 above, 2 below, so the amplitude is 2. Now your period, you can start here, goes up, down, and repeats itself back to here. And as you can see, that has a period of pi. And we'll continue to examine what do these things mean, but for today, we're just practicing identifying these 3 characteristics of the wave function. So if we look at this one, its minimum is at negative 5, maximum's up here at 5. So that one actually is going to have a midline right on the x-axis. You have 2 options. You could write the x-axis, or the other option, y equals 0. Okay. Now the amplitude is both 5 above and 5 below. So amplitude is 5. And it starts here on the y-axis, goes up, and then down, and then it will end right here. This one's maybe a little goofy, but 10 pi over 3 would be our answer. Okay, so that's all I have for today. There is a Delta Math assignment. Please go ahead and try to complete that. And then remember, on Monday there will be a Desmos activity. You're going to kind of have to go through that on your own. I think I've put you guys in a position to find success, but if you need help, just continue to try things. If you have to, ask your classmates, see what you can do, and then on Tuesday I'll be back to give the next lesson. So hope you guys have a great day, and I'll talk to you later.